Welcome again, ladies and gentlemen. Talking about an induction system with a permanent magnet alternator, which is run at 130 RPM, which produces 12 volt DC at 14 amps. And we have an induction motor here, which is using 120 volt AC at 60 cycle to produce, to create the permanent magnet alternator to generate energy. Now, the energy produced from this permanent magnet alternator can be introduced into a series or capacitor bank, where then the capacitor bank can be also discharged back into the induction motor to self-sustain the system. Or another way where you can charge using it, adjusted at a low voltage, low RPM, charging a battery up, then using an inverter where you can invert the energy back into the induction motor. This system also can use a battery isolator. Isolator means you can charge one and run one at the same time and continue the cycle. This induction motor system is one of the simplest self-sustained generator system. The only thing is to maintain is the heat transmitting from the induction motor, where a fan can be mounted in this area to keep the system cool. Now, by introducing it to the capacitor bank, or bank of capacitors, these capacitors are no PCBs, run capacitors from air-conditioned units, rating away from 5 microfarad up to 40 microfarad, and sometimes 108 microfarads. With a total capacitance of 840 microfarads, adjusting at that 60 cycle, the system can be self-sustained, wherein is the induction motor can be getting energy from the capacitor bank. Capacitor bank gets energy from the alternator, which is turned by the induction motor, which is also keep the system self-sustained. And another series of charging banks of batteries anywhere from 12 volt to 36 volt, 48 volts batteries, converting some of the battery energy back into the induction motor to keep the system self-sustained. This system basically is explainable how the energies are transmitted back and forth. The system also is started from an external source, and has to maintain the right frequency and speed and RPM. It can be self-sustained. The outside source could be an alternating current, like an AC current, and we're going to do a test to see how the system works. By energy is in the system, we can put a great amount of force into a unit. So right now we're running, charging the system, and those will get charged up, and we can discharge it back into the unit while we disconnect from the wall. And the next step, it can be set up so that it will be self-sustained and have a cooling fan. Keep it cool. Charging batteries, self-sustained energy, another way of alternating or saving energy in case of an emergency. These devices are built just for the sake of emergency, not for constant use. So the system does have a heating problem, where an induction motor need to get a heating system set up to keep it cool. That's one of the major downfalls of the system. Once this is generating the high RPM, which is more than it's about 1,000 RPM, which is increased up to 48 volts, you can light up light bulbs or any other source of energy from the alternator. The next test, we'll see how our light bulbs are ignited to the alternator. Now, we're going to test the light bulb to the system. See how it works. difficulties with that part. The system can be self-sustained once this capacitor is charged at the right frequency, which is 60 cycles per second. It can be discharged back into the induction motor. Thank you, ladies and gentlemen, again. Another series of our induction motor can transfer energy into a magnetic alternator, permanent magnet alternator, and get charged back through an electromagnetic field into the induction motor. Thank you very much.